Hi, it's me, Paula, the math tutor. In this video, we're going to discuss expected value. We are going to be able to calculate what to expect to get in a random experiment if we repeat it over and over again. For that, first we are going to define what expected value is, we're going to see how to calculate it, how to find it, and then we are going to work with two examples. So, let's begin. Expected value is the long-term average or mean of a random variable if the experiment were to be repeated infinitely. If we have a discrete random variable x with possible values x1, x2, x3 up until xn and a probability distribution p1, p2 up until pn, then we're going to calculate the expected value as e of x equals the sum from 1 to n of xi times pi. So we're going to multiply the values of the variable times their associated probabilities, and then we're going to add them up. Basically what we're doing is we're calculating the mean for this variable. E of x, the expected value, is the mean of the probability distribution of x. It is sometimes denoted with the Greek letter mu as well as e of x. And what expected value does is it takes into account all the possible values and weights them by the probability of them happening. What we're doing by multiplying them is weighting each of the results by the probability of them happening, and then we add them all up so we get the mean result of all of that. Basically, expected value is the result we can expect to get if we repeat the experiment infinitely, or many times at least. Let's start with the first example. For this example, we are going to play a game. I'm gonna ask you first to pick a letter from the first 10 letters of the alphabet, so from A to J. And then I'm gonna ask you to pick a number between 0 and 9, inclusive. If your choice exactly matches mine, you get back your bet plus 10 times your bet. If your number matches, only the number, you get back double the amount you bet. Otherwise, you lose your bet. Let's see what you can expect to get in this game. Imagine then you play this game with me 100 times. How many times you should expect to match overall? Just match the number or lose? Let's summarize this in a table. So, the possible outcomes are: you can match it completely, letter and number. You can match only the number, or you can just not match anything and then you lose. The probability of an overall match, if we have 10 letters and 10 numbers, there are 100 different outcomes and only one of them works for us. So the probability of an overall win, it's 1 over 100. Then the probability of just matching the number would be 9 over 100. It's not 10 over 100 because if I match the number with the letter, that's one of the 10 possible outcomes of matching the number, matching also the letter, so that one is included in the previous one. If I match only the other 9 numbers, then the probability of matching them is 9 over 100. And then the probability of losing completely would be 90 over 100. And let's say we want to calculate how much money you should expect to win or lose over each game. Let's say you bet $1,000 each time. How much would you expect to end up with if you play 100 times this game? Well, let's calculate the expected value. We need to multiply the possible outcome, the number associated with the possible outcome, with the probability of it happening. The first outcome is winning completely, guessing the letter and guessing the number. That will give us $10,000 because we bet 1,000 and they say they are going to return 10 times what we bet. The probability of that is 1 over 100, so I need to do 1 over 100 times 10,000. Then I could just guess the number. The probability of that is 9 over 100, and the rules say that if I just guess the number, they will give me back twice what I bet. 1,000 back times 9 over 100. And then if I lose my bet. So I end up with negative 1000 times the probability of that happening, and that is 90 over 100. So I end up with 1 over 100 times 10,000 plus 9 over 100 times 1000 minus 90 over 100 times 1000. And that gives me negative 710. If you play this game 100 times, you can expect to end up with $710 less than when you started. And for the next example, if you remember the video about mode and median, you may recognize this example. We have a physics class with two teachers, Mr. Bohr and Mr. Blank. And we have the results of that IB physics class. For Mr. Bohr and Mr. Blank, like the possible grades that the students can get go from 1 to 7, and we have the probabilities for the students to get each of those results. The proportion of students in Mr. Bohr's and Mr. Blank's classes that got a 1, a 2, a 3, a 4, up to 7. We have the tables with the results. Let's say we want to find the expected scores for both classes. We want to know what a student that takes this class may expect to get when taking it. So for Mr. Bohr, what we're going to do is we are going to calculate the expected value. That means that we're going to multiply each of the results, each of the grades that the student has got, times the probability of getting it, and then adding everything. And that gives you 3.45. So a student taking Mr. Bohr's class can expect to get an average of 3.45 in the grade. Let's see what happens with Mr. Blank. That gives you a 4.52, meaning that the expected value, the expected grade a student can get in Mr. Blank's class, it's higher than in Mr. Bohr's. Were you to choose one or the other, you should choose Mr. Blank's. In these examples, we've been calculating what you should expect to get, and that is very useful to make decisions. Making decisions is exactly what we're going to discuss in the next video, which is going to be about fairness. Deciding if a random situation is or not fair. For example, if you're playing a game, is the result fair? What does it mean for something to be fair? All of that is going to be in the next video. Bye bye!